Hello students. So in 11th standard business maths and statistics, the very first chapter is matrices and determinants, and in 10th standard we had learnt some ideas about matrices, so we have to recall that before starting the chapter. Right. First one, matrix. What is a matrix? A matrix is a rectangular arrangement of number of numbers in horizontal lines called rows and vertical lines called columns. The numbers are enclosed in a square brackets or an open bracket or pair of double bars. It is denoted by capital A, capital B, capital C. Usually the matrices will be represented by capital letters, right? And the entries inside the matrix will be represented using small letters. So here they have given example capital A equal to 142,586. So they have given two rows and three columns. You can see first row is 142, the horizontal line, and second row is 586. So two rows, and they have three columns also. You can see the first column is 1 5, second column is 4 8, third column is 2 6. Right. So like everybody has a unique weight and height like that. The matrices will also have a separate size, so otherwise it is called the order of the matrix. So if A is a matrix has m rows and n columns, then A is called a matrix of order m cross n. For example, if A equal to, they have given A equal to 142,586, then in this matrix A you can see two horizontal rows, right, or two rows and three columns. So therefore the order of A is 2 cross 3. So 2 cross 3, here 2 must be the rows and 3 is the columns. Always you have to write the number of rows at first, then number of columns in the second. So 2 cross 3. And now we are going to see the types of matrices. So this also we had seen in the last year. So types of matrices. So first one, row matrix. A matrix having only one row is called a row matrix. For example, they have given A equal to only one row. You can see the elements. There may be many columns, but the matrix will be having only one row, right? The another one is B equal to, we have 1 2, right? So we have only one row and two columns in that, so it is 1 cross 2, right? So what is column matrix? Obviously a matrix which have only one column is called an column matrix, right? So in that you will be having only one column. You can see the example, A equal to A11 A21, like that. Vertically you have only one column, like that. B equal to 3 minus 5. In this you have two rows, but you have only one column, right? So this is why it is called a column matrix, right? What is zero matrix? Zero or null matrix? Zero matrix means in this matrix all the entries will be zeros. Okay, so that's why it's called a zero matrix. If all the elements of a matrix are zero, then it is called a zero matrix. It is represented by an English alphabet O, capital O, right? And this particularly, this zero matrix can be of any order. It can be of any order. It can be 1 cross 1 or 1 cross 2, 5 cross 3, any order it can be possibly, right? The next one is square matrix. In the name itself you can see square. So what do you mean by square? All sides will be equal. So like that also here, if the number of rows and number of columns of a matrix are equal, then it is called a square matrix. For example, A equal to 8 2 4 2. So in the first row you have 8 and 2, second row you have 4 and 2. How many rows you can see? You see two rows. And how many columns? Two columns. So it is a square matrix of order 2. Square matrix of order 2 means two rows, two columns, right? In the same thing we have another example, B equal to 3 minus 1 0 root 2 0 5 2 2 2 3 by 5 minus 4. In this matrix you can see three rows and three columns. Therefore you can say it is a square matrix of order 3. So now we are going to see triangular matrices. A square matrix whose elements above or below the main diagonal or the leading diagonal are all zeros is called a triangular matrix. So in this you can see example, A equal to, in the first row 1 2 3, the second row 0 2 4, third row 0 0 5. So in that I have made a red color arrow that represents the diagonal 5 to 1. So below that you can see the bottom of the matrix. You can see below that red color line diagonal, the 1 2 5, below that you can see all the entries are zeros. So either like that it will be, or in the next matrix B you can see 1 3 7, the diagonal. Above that you have all the entries as zeros. So these types of matrices are called triangular matrices. So next one is diagonal matrix. So in this one, particularly the elements will take only along the diagonals. You can see a square matrix in which all the elements other than the main diagonal elements are zero. So only in the main diagonal you will have entries. For example, A equal to 500 020 in that the red color arrow thing you can see there is a diagonal along that 5 to 1. Only in that diagonal you have numbers, except that you can see only zeros, right? So it is a diagonal matrix of order 3. Now the next one is scalar matrix. So what is scalar matrix? A diagonal matrix with all the diagonal elements are k, that is a same constant, then that is called a scalar matrix. So scalar matrix is basically a diagonal matrix in that all the entries in the diagonal will be same. You can see 5 5 5, right? So it is basically a diagonal matrix and all the elements are same, so it is called a scalar matrix, right? Next one, unit matrix. Unit matrix is also a diagonal matrix in which all the elements on the diagonal in the diagonal will be same, and that same number will be 1, right? So 1 or unity, both are same. That's why it is called a unit matrix, right? So for example, I2 means 2 row 2 column matrix. In that you can see 1 0 0 1, the diagonals are 1 1, right? I3 means 1 0 0 0 1 0 and 0 0 1. In this also the diagonals are 1 1 1, which is a unit matrix of order 3. So now we are going to see this multiplication of a matrix by a scalar, right? So let me go start with the example for this. Scalar means a constant. So multiplication of a matrix by a constant. So here the example is A equal to 1 2 4 in the first row, and the second row 3 minus 2 8. Then 2a means you have to multiply the matrix A by 2. So it becomes 2 into 1 2, 2 into 2 4, 2 into 4 8, and 2 into 3 6, 2 into minus 2 minus 4, and 2 into 8 16. So this is nothing but multiplication of a matrix by a scalar. Next topic is negative of a matrix. It's quite simple. The example you can see, if A is equal to, the entries are 2 minus 5 7 and 0 5 6, then minus A, the negative means the negative sign we have to give it, we have to multiply with the matrix. So when you multiply with the matrix you have to give it to all the elements in it. So minus A equal to minus 2 5 and 7 0 minus 5 and minus 6, right? And the next one is equality of matrices. Equality, the word itself, it defines two matrices A and B are said to be equal if they have the same order. Same order means the number of rows and number of columns must be equal. Then the corresponding elements are also equal. All the entries must be same and the order must be equal. Okay, so this is the important topic which we need to learn for this year. So this is about determinant. Okay, let's see the definition. To every square matrix A, to every square matrix A of order n with entries as real or complex numbers, we can associate a number called determinant of a matrix, and it is denoted by modulus symbol. You can use A, right? Or actually it must be pronounced as determinant of A, not modulus of A, but usually we use the modulus symbol, so that's why I told you. But hereafter we have to pronounce it like we have to say it like what, determinant of A, or det of A, det A, or delta. This is also determinant. So the three formats are acceptable, so keep in mind, right? So now determinant means it's nothing but for every square matrix there will be a value associated with it, and that value is called the determinant value of the matrix, right? So using this only we are going to do in many sums in the upcoming exercise. So let's see how to find the value of the determinant. So here they have given an example, A equal to The first entries are A11, A12. So the second row entries are A21, A22. Then its determinant of A equal to determinant symbol. Determinants means we have to remove the regular matrix brackets and we have to put only straight lines. So you can see the difference here, A and determinant of A, right? Okay, after doing that, you have to multiply, you have to cross multiply the entries. So A11 with A22 you have to multiply, then you have to put minus, and then you have to cross multiply this side, left leading diagonal, A12 with A21. That's all. So this, when you subtract, you will get an answer, and that is going to be the determinant of A. Okay, now we are going to see the topics following determinants, that are minors and cofactors. So when we see the minors and cofactors definition wise, we have to go a bit different. But when we see to the sum, we can understand much quicker. So let me give the examples for you about minors and cofactors. First one, we deal with minus. Here, I have taken a matrix A, right? In this, the entries are 5, 1, 2, 3, right? So now I want to find the minor of 5. Then keep in mind the row which contains 5 and the column which contains 5, leave it, ignore that. So neglect the row and column in which the 5 is present. So cut the first row and cut the first column. What is remaining? 3, and that is the answer. So what is minor of 1? The 1 present row and the 1 present column, that you have to leave it. If you leave that, what is the remaining number you can have? 2. That's all. So what is the minor of 2? So minor of 2 means the 2 present row, that is in the second row and the first column. So that you have to leave it. If you leave that, then what will be remaining? 1. Right. What is minor of 3? That's all. The 3 present row, that is second row, the 3 present column, second column, you leave it. So what is the remaining entry you will be having? 5. And that these are the minor concept. So when you give the alternate plus minus symbol, you will be getting the cofactors. That's quite simple. You can see on the right side, A equal to the matrix I have written, the same matrix 5, 1, 2, 3. But over the first row, I have given what sign? You can see plus minus. And for the second row, here I can see, you can see this 2, 3. Below that I have given minus plus. So the first sign again must be starting with plus. First row plus minus. The second row sign again must start with minus. So minus plus. Now in these answers we have minor, right? The left side you see the minors are what? Minor of 5 is 3. What is above here? Above 5, what sign we have? Plus. So assign it. So for this 3, if you assign plus, you'll be getting plus 3. That becomes, the minor will become cofactor when you multiply the sign with the minor. That's all. Okay, what is the minor of 1 here? 2. Now for 1, what sign we have? Minus. So multiply the minus with this answer of minor of 1. So minus 2, right? Now what is the minor of 2? Minor of 2 is 1. For 2, what sign I have here? Minus. So minus 1. So what is the minor of 3? It is 5. But what is the sign I have below 3? Plus. So plus 5. That's all. Using this, if you write a matrix, and that matrix is called a cofactor matrix, right? That's all. Now we are going to find the determinant value. The matrix is 5, 1, 2, 3. Now we are going to find the determinant value of this matrix. That is very easy. Now write the entries, but don't use the matrix. We are going to apply the determinant symbol. So determinant means the straight lines applied. So determinant A equal to determinant of 5, 1, 2, 3. Now over the first row, you must always assign the plus minus symbol. So plus minus I assign. Now cross multiply. Plus, below the plus sign, what number you have? 5. So cross multiply with 3. So 5 into 3. Plus sign is there. So plus 5 into 3. Right. Now the remaining entries 1, 2. But above 1, what we have? Minus. So put minus. And now multiply 1 and 2. 1 into 2. 5 3s are 15. Minus 1 into 2. So 15 minus 2 is 13. And now we are going to learn how to find the minors and cofactors for a 3 by 3 matrix, that is 3 row 3 column matrix. Okay, so the given matrix is 3 1 2 and 2 2 5 4 1 0, right? First, let me take the matrix and I put determinant symbol. So determinant A equal to determinant of. Over the first row, I put sign plus minus plus. So what I told you for the first row, for that we have to assign the symbol with plus. So plus minus plus. So that the second row must start with minus. So minus plus minus. So the third row must be doing what? Plus minus plus. So that's all. That's a simple logic. And now we are going to find the minor of 3. Right. If you want to find the minor of 3, then take this matrix A. In that, the 3 present row, that is the first row, and the 3 present column, that is the first column, leave it. What are the remaining entries you can see? You can see only the 3 present. I will show it here. 3 present row and 3 present column. If you hide it, you will be getting 2, 5, 1, 0, right? So that I write it in a determinant. I have to write the 4 elements in a determinant, and I have to put plus minus sign over the first row. Now I have to solve this. So how can I solve? The plus 2 you have to cross multiply with 0. So 2 into 0, 0. Then the minus 5, that is 5. Above that we have minus, so minus 5. We have to multiply with 1. So 0 minus 5 is minus 5. Right. So how can you find minor of 1? That is simple. So go to the matrix A. The second row, so first row, the second column, you can see a 1, right? That 1, you have to hide that row and column. If you hide that row and column, you will be having 2, 5 and 4, 0. So apply that entries in a determinant and give the plus and minus sign over the determinant. So you'll be having plus 2 minus 5 4 0. So plus 2 into 0 0, minus 5 into 4 minus 20. So 0 minus 20 is minus 20. So like that you can find for all the 9 entries. So you're getting the entries like this, right? Can you see? You get minus 5 minus 20 minus 6 minus 2 minus 8 minus 1 11 1 11 4, like this. Now how can you transform these all into a cofactor? So that's quite simple. We have signs here. You can see the blue color, plus minus plus. So for that, minor of 3 means the answer is minus 5. With that, multiply the sign. So plus into minus 5. So what is it? Minus 5. Next one is the minor of 1 is minus 20. What sign we have above 1? Minus. So minus of minus 20 will become 20. So like this, if you do, you will get the cofactors. And another easy way, only for 3 by 3 matrix, after finding the minors, put first plus the minors answer. First you give plus sign, next you give minus, plus minus plus minus plus minus, like that. So alternately if you give, automatically the minus will become cofactors. So now we are going to see how to solve a determinant. It's very easy. First we will start with 2 by 2 here. B, determinant of B equal to determinant of 5 7 2 3. I told you, whenever you solve the determinant over the first row, you have to give plus minus sign. Okay, given. Now take the 5 and multiply with 3. So plus 5 into 3. Then minus is there above 7. So minus 7 into 2. So 5 into 3 15. Minus 7 into 2 14. So 15 minus 14 becomes 1. So what is the value of the determinant? Determinant of B equal to 1. Right. So this is for 2 by 2 matrix. So it's easy, right? And now we are going for a 3 by 3. That is 3 row 3 column. You can see here determinant of A equal to 3 1 2 2 2 5 4 1 0. Actually here we have 3 rows and 3 column. You can expand the determinant by choosing any one row or any one column. So I'm going to choose the first row. That's why I've given a red color arrow mark. Right. Over the first row, then you have to assign the sign. So what is the sign we assign? So plus minus plus. Okay. Now take that plus 3. Right first. Okay. Now leave that 3 present row and column. That is the first row and first column, you leave it. Now what are the remaining entries you'll be having? 2 5 1 0. Take that and put in a determinant and multiply with 3. That's all. So 3 into determinant of 2 5 1 0. Right. Next is minus 1. So 1 is there actually, but above that we have minus in red color. So that's why minus 1. Now see that the minus 1, that row that is present in the first row and second column. So leave the first row and second column. So what are the remaining entries we can have? 2, 5, 4 zeros, and that thing you have to put in a determinant and you have to multiply with minus 1. Okay, now the last entry in the first row is 2. Now take the 2. Now the 2 is present in the first row and third column, so leave that first row and third column. What are the entries we'll be having? 2, 2, 4, 1. Put in a determinant and multiply with plus 2. That's all. Now how will you solve this 2 row 2 column determinant? That is an easy process, we all know. Put over the first row, put plus minus sign in all the three. Now 3 of multiply 2 with 0, so 2 into 0 0, then minus 5 into 1 minus 5, so we have 0 minus 5, it is minus 5, so 3 into minus 5. Okay, now like that. Next, minus 1 of determinant 2540, so above 2 we have plus sign, so 2 into 0 0, above 5 we have minus, so minus 5 into 4 minus 20, right? Plus 2 of determinant 2241, so above 2 we have plus sign, so plus 2 into 1 2, and then above 2 we have minus now, so minus 2 into 4 minus 8, so 2 minus 8 minus 6. So while solving like this, we get the answer minus 7. So this is the way we have to solve a 2 cross 2 matrix or a 3 cross 3 matrix to find its determinant value. Okay, so now we are going to see the properties of determinants. Okay, actually it is given in your textbook without proof. So there are totally 7 properties, out of which the first 6 are very important, and each and every property I want to give it with an example, then only you can understand. So here comes the property with a proof. Okay, first property. The value of a determinant remains unchanged when rows and columns are interchanged. Okay, let's see. So here I'm going to take a determinant of A equal to determinant 3142. You know how to solve. Over the first row we have to assign the plus and minus sign, so it is assigned. Now multiply plus 3 with 2, so 6, then minus 1 with 4, minus 4, so we got 6 minus 4, so we have 2. So that's the answer. Now what they say, when the rows and columns are interchanged, then there will be no change in the value. Okay, let's change the rows and columns. Actually, what is the first row here? 3 and 1. What is the second row entries? 4 2. If it is taken a transpose, then it will become like this. Am I right? 3 4 to the first column will become the first row, and the second row will become the second column. Okay, that's all. So now we have got a transformation. Now it is the transpose of the first one. Now also we are going to find the determinant value. So for over the first row I give plus minus sign. Now multiply the plus 3 with 2, so 6. Now multiply minus 1 with 4, so 4. So 6 minus 4, 2. So even though the values are interchanged, I'm sorry, so determinant of A equal to 3 4 1 2, so plus 3 with 2 6, then minus 4 with 1 4, so we got 6 minus 4 2. So even though the transpose is done, the value of the determinant is not changed. So that's what they say, the value of determinant remains unchanged when the rows and columns are interchanged. Property number 2, if any two rows or columns, that is any two rows or any two columns, are interchanged, then the value of the determinant changes only by its sign. Okay, let's see. So here on the left side you can see the determinant has entries 5 1 in the first row, and in the second row we have 2 4, right? While solving this, over the first row we have to put plus and minus sign, and now we are going to solve 5 into 4 20, then minus 1 into 2 minus 2, so the answer is 18. Okay, now what they say, when you interchange any two rows, so now here you can see in the left side the determinant, the first row entries are 1 5 and 1, the second row entries are 2 and 4. Now I'm going to interchange them, that is first row is going to take place in the second row's place, and second row is going to take place in first row's place. So 2 4, right side you can see determinant of A equal to 2 4 5 1, and now I am going to solve. So over the first row I am going to give plus and minus sign, so plus 2 into 1 is 2, then minus 4 into 5 is minus 20. What is the answer? Minus 18, right? So now you can understand, when you interchange any two rows, the value of the determinant changes only by its sign. So the value is same, 18 18, but the left side we have plus 18, right side we have minus 18. That's why they say the value of the determinant changes only by its sign, Okay, not by value. Property number 3. If any two rows or any two columns of a determinant are identical means looking same, then the value of the determinant is 0. That's very easy. So here you see determinant of A equal to, they have given a determinant. In the first row we have 1, 2. Second row also we have 1, 2. Can you see the first row and second row same? Yes, they are same. So therefore the answer will be 0. Directly you can write 0. But for you to understand, I have proved here. So now over the first row, I am giving the symbol plus and minus sign. Now multiply the plus 1 with 2, so you have 2. Then the other side minus 2 with 1, so you have minus 2. So the answer is 0. So whenever we have two rows identical, looking same, or any two columns looking same, identical, then the answer of the determinant is 0. So now property number 5. If any two rows or any two columns of a determinant are proportional, then the value of the determinant is 0. Okay, so what do you mean by proportional? So here I'll give you an example. Here determinant of A equal to determinant in the first row 1, 2, 3, the second row 2, 4, 6, the third row is 1, 1, 1. Here you can say the first row and second row are proportional. You know why? The first row is 1, 2, 3. When I multiply any number with this row, if I'm able to get another row, then that time we can say the two rows are proportional. Can you get me? I repeat again, when you multiply any number with the first row or any other row, if you are able to get any other row in the same determinant, then those rows are called proportional. Here you can see the first row we have what? 1, 2, 3. Now just multiply 2 with the first row. So what will you have? 2 into 1, 2, 2 into 2, 4, 2 into 3, 6. Do you see it in the second row? That's why. So first row and second row are proportional. So the answer is going to be, determinant answer is going to be 0. But why they say the determinant answer is 0 when they are proportional? The reason is here. Here the determinant I have taken 1, 2, 3, 2, 4, 6 and 1, 1, 1. As I said in the last property, if you find any common multiple in any row or any column, you can take the common multiple outside. That is the constant outside. First 1, 2, 3, there is no common multiple. 2, 4, 6, we have a common multiple. What is it? 2. If I take 2 outside, then the second row will be like 1, 2, 3. Now see this. First row and second row looks same. 1, 2, 3, 1, 2, 3. If any two rows are identical, that means same. The determinant answer is 0. Without solving, we can write. So 2 into 0, 0. So this is the reason why they say for proportional rows also the determinant value is 0. So we have to keep in mind, in two cases the determinant will become 0. One, if any two rows are identical, that is looking same. Another one is two rows are proportional, that is one row can be obtained from the other by multiplying any number. Property number 6. If each row in a row or a column of a determinant is expressed as the sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants of the same order. Okay, if you see the example, you can understand this property. Now here you see in this left side, I have got determinant, that is determinant of x plus a, y plus b, z plus c. Under the second row x, y, z, and the third row a, b, c. Now I want to solve the determinant. So what can we do now? For this one, what they say, the first row you can see all the elements are two terms. Each and every element has two terms. Then keep the first term in each element. What is the first term in each elements in the first row? X, Y and Z. Keep that and then write the second row, third row same. Plus, and now what is the second term in the each elements in first row? A, B, C, and keeping that we can write a determinant. Hope you understand that. So this is the property number 6, and here I have made the answer 0. Why? In the first expanded determinant you can see first row and second row are looking same, identical, so 0. And in this one you can see the first row and third row are identical, so also the answer is 0. So 0 plus 0, 0. So how do you do this? If any row has two terms, then keep the first terms and form one determinant, and keep the second terms and form one determinant. That's all. So students, so to carry out all the sums and to easily do all the sums in this chapter, you need to deeply learn this determinant concept. Take time and learn, and based on this only we are going to do almost all the sums in this chapter. Thank you.